Hello everyone, welcome to our channel Vijnanamastu. Today's chapter is on chemical reactions and equation. We all know that there are many changes occurring in our surroundings. It might be physical changes, chemical changes and so on. Let us look at some chemical changes happening. An example is an iron nail getting rusted. Respiration, we take in oxygen and release carbon dioxide, and there are many chemical reactions happening in between. Digestion, the food we take in undergoes several chemical reactions. The food we eat, while it gets cooked, you put fresh vegetables and then it gets cooked into something delicious you like. And the conversion of milk into curd. These are some of the examples of chemical reactions. We tend to learn these theoretically in the form of chemical equations. Consider burning a magnesium ribbon. It changes into something powdered substance, and you can see a very bright light. It's harmful if you see with your naked eye, so be careful if you are going to try this experiment. So now we tend to study this experiment in the form of equations. So, chemical equations. Magnesium reacts with oxygen in the air to give magnesium oxide. Here, magnesium and oxygen are the ones which are undergoing reaction. So, we call them as reactants. And magnesium oxide is what we get in the end. So, it is called as product. So magnesium is represented by Mg, oxygen by O2. It is a diatomic molecule, as you all know, and we get MgO. So is this chemical equation complete? There is something missing here. What is it? Yes, the balance. There is no balance in this chemical equation. Why is it so? Because you can see in the reactant side, oxygen, there are 2 atoms, but in the product side, only 1 atom. So, we need to balance it because it should follow conservation of mass, which states that mass can neither be created nor be destroyed. So, let's see how to balance a chemical equation. There are few steps you need to follow. First step, write down the equation that has to be balanced, Mg plus O2 giving MgO. So next step is list down the elements present in the reactants and product side. So first element is Mg. In the reactant side there is only 1 atom, and then the product side there is 1 atom. Okay, oxygen. In the reactant side there are 2 atoms, and in the product side there is only 1 atom. So we need to balance this. So what do we do now? In the RHS we need to multiply by 2. So where should I multiply by 2? Here I have to multiply by 2. So that becomes, so multiply by 2. And that becomes Mg plus O2 giving 2 MgO. Now oxygen atom is balanced, but magnesium atom remains unbalanced. So what do we do now? 2 Mg plus O2. Here we multiply by 2. So now what you get is 2 Mg plus O2 giving 2 MgO. Now both the elements are balanced, but it is still incomplete because you have to write down the symbols of its physical states. Magnesium ribbon was in solid state. It reacts with oxygen in the gaseous state to give magnesium oxide, the powdered substance you get in the end. That's also solid. So this is a balanced chemical equation. Let us look at another chemical reaction. Zinc granules, when you put them into dilute sulfuric acid, they completely get dissolved. Where do they go? The zinc reacts with sulfuric acid and releases hydrogen gas. And that hydrogen gas comes out through this glass tube outside. And if you bring a sparkle here and the gas catches fire, as you all know, hydrogen gas catches fire easily. So let us write it in the form of equation. Zinc plus sulfuric acid gives zinc sulfate plus hydrogen. So Zn plus H2SO4 gives ZnSO4 plus H2. Is this equation balanced? Yes, it is already balanced. Now let us look at balancing a much more complex equation than before. So Fe plus H2O giving Fe3O4 plus H2. This is ferrous ferric oxide. Okay, so the first step is to write down the equation which needs to be balanced. Next step is list down the elements present on reactant and product side. So the first element is Fe, LHS, there is only one, RHS, there are 3 atoms, hydrogen in the LHS there is 2, and in the product side there is also 2. Next is oxygen, in the LHS there is 1, in the RHS there are 4. So now the big question that comes to your mind is which element do I start with, or which molecule do I start with balancing? So you have to select the molecule with maximum number of atoms. Which is the molecule with maximum number of atoms? This is it, Fe3O4. Another question that comes is which element among Fe and oxygen should I select? See, if you select Fe in the LHS, you can see that it is in the form uninuclear molecule. Uninuclear molecule means in that molecule only one type of atom is there. Here it is heteronuclear molecule. Hetero means more than one type of atom. So you have to keep the uninuclear molecules for the last, because it's easy to just add the number how much ever you need here, right? So we start with Fe3O4, then go to H2O, and then to H2 and Fe. So in Fe3O4, as I told, Fe will keep it for last. So let's start with oxygen. So here LHS you have to multiply by 4. So when you do that, you get Fe plus 4H2O giving Fe3O4 plus H2. Now what? Next, what to do? Let's look at hydrogen. So in the LHS there are 4 into 2, 8 atoms of hydrogen, and in the RHS there are only 2 atoms of hydrogen. So here we will multiply by 4, and this is what you get. Now the oxygen is balanced and hydrogen is also balanced, and the final thing to do is to balance ferrous Fe atoms. So this is what you got in the previous step. Now what to do? Here we should multiply by 3. So 3Fe plus 4H2O giving Fe3O4 plus 4H2. Now the equation is balanced. But we need to do one thing, right? Yeah, you have to write the physical states of reactants and products. So 3Fe plus 4H2O, this is in solid state, this is in gaseous state, Fe3O4 in solid state, and H2 is in gaseous state. So yes, now you got the final chemically balanced equation. Now let us move on to the topic types of chemical reactions. What do you see here? These both people are getting together and becoming one. They are getting combined. So in such reactions, first we are going to look at combination reaction, where more than one reactants get combined to become one single product. Let us look at an example. Calcium oxide reacts with water to give calcium hydroxide. You can see here only one product is there. So calcium oxide is also called as quicklime. Calcium oxide is called as quicklime, and calcium hydroxide is called as slaked lime. So in this reaction a single product is formed. Hence, this is a combination reaction, and this is the definition. Some facts. As I told you, calcium oxide reacts with water to give calcium hydroxide. But where is this used? This is nothing but the whitewash we use for our walls. This thing is painted on the walls. So calcium hydroxide is painted on the walls. Carbon dioxide in the air reacts with calcium hydroxide to give calcium carbonate, and that gives a shiny finish to the walls. A few more examples of combination reactions. Let's look at them. So burning of coal. Here carbon reacts with oxygen to give carbon dioxide. Here you see only single product is formed, hence it is combination reaction. Another example is the formation of water from H2 and O2 molecules, gaseous molecules. So here also single molecule is formed. One more thing friends, you have to notice these two reactions release heat. They give out heat energy. Such reactions in which heat energy is released, they are called as exothermic reactions. And the reactions in which heat is absorbed, energy is absorbed, they are called as endothermic reactions. A few more examples of exothermic process. Respiration is an exothermic process. We all know that we get energy from food. We know that food gets digested by the digestive system, but the energy from food is extracted by respiratory system. Like respiration is the process you take out energy from food. The food you eat breaks down into glucose, and this glucose reacts with oxygen we breathe in to form carbon dioxide, which we release out while we exhale, and water and energy. So this is about respiration, a short intro. And then another example for exothermic process is burning of methane gas. That is, methane is CH4 that reacts with O2 giving CO2 plus H2O. So these are examples for exothermic reactions. Next, let us look at decomposition reaction. What do you mean by decomposition? Breaking down. So when something gets broken down, it is called as decomposition, right? Let us look at an example for this. So here we have taken a ferrous sulfate crystal. When we heat this ferrous sulfate, it gets converted into something like this. That is nothing but ferric oxide. So what is actually happening here? Ferrous sulfate, when it is heated, gets broken down into these many products. Here what you see is a single reactant is being broken down to simpler products. Hence we call it as decomposition reaction. So this is the definition. Some other examples for decomposition reaction is heating of limestone, that is calcium carbonate. When it gets heated, calcium oxide and carbon dioxide is formed. We just saw this in the combination reaction, right? So the reverse process is seen here. Another example is heating of lead nitrate, and it gets broken down into lead oxide, nitrogen dioxide and oxygen. Here you see the reddish brown color. This is the color of the gas nitrogen dioxide. Next, when silver chloride is kept in sunlight, it gets broken down into silver and chlorine. The chlorine gas escapes as gas, and silver remains as a silver colored solid in the china dish. So these are the examples for decomposition reactions. Displacement reaction. Let us start with an example. So let us consider an iron nail is kept in copper sulfate solution. After a while you can see that the copper sulfate solution loses its identity, that is the blue color. It gets lost. The blue color is no more. It becomes colorless. The solution becomes colorless, and also you can see a reddish brown colored deposit on the nail. So what's happening here? Let us look at it. So the ferrous in the iron nail replaces copper in copper sulfate, and you get ferrous sulfate and copper solid. So this is nothing but the reddish brown deposit you see. This is deposits of copper atoms, and ferrous sulfate is colorless, that is aqueous state. It is colorless, hence the liquid is colorless. Other examples of displacement reaction is zinc replaces copper in copper sulfate, and you get zinc sulfate and copper, and also lead replaces copper in copper chloride, and you get lead chloride and copper. So why does this actually happen? you can consider an example. This doggy, it has a bone with it, and there is meat here. This doggy likes meat more than bone, so it leaves the bone and grabs the meat. Similarly, here sulfate ion likes ferrous atoms more than copper. Hence, it leaves copper and gets combined with ferrous. So the affinity of sulfate towards ferrous is more. Hence, this displacement reactions happen. I hope you understood what I meant. Next, let us look at double displacement reactions. Consider an example where sodium sulfate and barium chloride, these two are aqueous solutions which are colorless. When you mix them, you get a white PPT. This white PPT is nothing but barium sulfate, that is the solid. So what is actually happening here? The sodium atoms and the barium atoms are being replaced in these two. So double displacement is what we call. Like the ions are being exchanged. So to better understand this doggy has carrot and this rabbit has a bone. This rabbit likes carrot more than bone, and doggy also likes bone more than carrot. Hence they discuss to exchange what do they have, so that they'll have what they want and which suits them better. So this is the displacement, double displacement reaction. This is the definition for that. Okay, now the last type is oxidation and reduction reactions. So let us look at this reaction. Copper reacts with oxygen under heat to become copper oxide. This copper atom gained oxygen. So any substance which gains oxygen is said to be oxidized. In few cases you can see that they lose hydrogen. So it's one and the same. Oxidation means a substance when it gains oxygen or loses hydrogen, it is said to be oxidized. Let us look at another reaction. Here copper oxide reacts with hydrogen under heat to give copper and water. Here what do you see? Copper oxide lost oxygen. It lost oxygen. So this is reduction. It got reduced. A substance which loses oxygen or gains hydrogen is said to be reduced. In any reaction, one substance gets reduced and the other substance gets oxidized. Such reactions are called as oxidation reduction reactions. Let us look at this. Here in the same example, copper lost oxygen, so it became reduced, but the hydrogen gained oxygen, hence it gets oxidized. So both oxidation and reduction are moving hand in hand here. Another example, zinc oxide reacts with carbon to give zinc and carbon monoxide. Here also zinc lost oxygen, so it is said to be reduced, and carbon gained oxygen, hence it is called as oxidized. So these are few definitions, different definitions for oxidation reduction. Removal or loss of electrons, it is called as oxidation. You'll understand this in the further lessons, further classes. And reduction is nothing but gain of electrons. Oxidation is also called as like removal of hydrogen. Reduction is addition of hydrogen. Oxidation is addition of oxygen, and reduction is removal of oxygen. So let us look at some of the effects of oxidation reactions. Iron chains, these metal chains getting rusted, and a copper substance gets such colored deposits on them. Why does this happen? Because metals, when they are exposed to the atmosphere, they are attacked by moisture or acids to form, and this results in the formation of metal oxides, which are much more stable than the metal atoms, and that causes tarnishing of these metals, and this is nothing but corrosion. So corrosion is an effect of oxidation reaction. Another thing, the food you eat, after some time it loses its taste and you can't eat it anymore, and also the oil, its color gets changed, and smell also, it starts smelling. This happens because the fats and oil content in food, they get oxidized, and that is called as rancidity. To avoid this, they put antioxidants to food or oil. And also to avoid corrosion, we paint them, we put oil on them, right? So rancidity and corrosion are some of the effects of oxidation reactions. So here we end the chapter chemical reactions and equations. Please, let's meet in the next video. If you like the video, please like, subscribe, and also share with your friends. Bye bye. Thank you.